All right, here's our third set of notes for Math of Personal Finance Term 1. Today, we're talking about compound interest. So last time we talked about simple interest, where you only earn interest on your initial investment. Compound interest, you get to earn interest on your interest, and the money adds up. So a couple of vocabulary quickly. APR stands for annual percentage rate. And APY stands for annual percentage yield. Okay, so your interest rate, that's like how much money like what percentage you're going to earn. And then your yield is actually how much money you did earn. And we'll talk about that more as we keep going. Okay, so compound interest. A big portion of compound interest, a big part of the formula, is understanding how often it's being compounded. Now, typically speaking, the more often your money is compounded, the more interest you're going to earn. So it's something to pay attention to based on like what the investment offer is. So if it is being compounded annually, now annually is every 1 year. Okay, it's just being compounded once per year. So, if your time, so since it's like compounded every 1 year, T is going to equal 1 because a whole year has to go by. Now, your interest is going to be compounded 1 time per year. So, the number of times, the number of cycles per year would be just 1. And this one's like kind of hard to understand because it's all just like 1, 1, 1, 1. You'll see it more as it comes as we build the rest of the formula. Okay. Now, if your account is going to be compounded semi-annually, so semi means it's going to be compounded every half of a year. So like 6 months go by and your interest is going to be compounded. And then another 6 months go by and your interest will be compounded again. So it will be compounded 2 times every year. So N would equal 2. Now if it's compounded quarterly, so every quarter of a year, every 1/4 of a year, it's going to be compounded. So every 3 months, your interest is going to be compounded. I guess on this one I should have written it would be every 6 months. So 3 months go by, your interest is compounded. Another 3 months go by, your interest is compounded. Another 3 months and another 3 months. So during one whole year, your interest is going to be compounded 4 times because there's 4 quarters in a year. So N would equal 4. Now, if it's compounded monthly, it's going to be compounded every 1 month. So every 1/12 of the year. And as the year goes by, it will be compounded 12 times. So your N would equal 12. If it's compounded weekly, this is every 1 week, your interest is being compounded. Now, there are 52 weeks in a year. Some people know that, other people don't. But trust me, there are 52 weeks in a year. So every 1/52nd of a year, your interest is going to be compounded. So every week that goes by, it's compounded, which means it will be compounded 52 times every year. So N would equal 52. And that's all because there's 52 weeks in a year. Now, if it's compounded daily, so every 1 day, there are 365 days in a year. So that's how often it's going to be compounded per year. So N would equal 365. Now, sometimes, this is the weird one, it can be compounded always. That's continuous interest. And that's kind of a different formula. We're not going to talk about that one today. Okay, now, We'll use this idea when we're plugging things into our compound interest formula because it's going to be very important to figure out what does n equal. And we'll base that off of how often they tell you it's compounded. And then we'll use this value based on the problem that we're doing. Okay, and one more thing I want to keep in mind. The balance of an account, that's your original deposit. We did this yesterday or whenever you did the last lesson. Your original amount that you put in the account plus how much interest you earn. That's how you find your balance in an account. All right, so continuing on. Oh yeah, this is just kind of an example about compounding frequency difference, okay? So if Lynn wants to invest his educator's bonus of $1,250 into a savings account, each offer offers the same 2.7% APR. So it's the same interest rate. They're all 2.7%. But they all have different compounding options. The table below shows the balance at the end of each compounding period. The boxed amount is the balance at the end of the first year. So this bank one is compounded annually. This is how much money he will get in his account after 1 year because it's just compounded one time. Now bank two, compounded semi-annually, he gets a little bit more money because it was compounded once here, and then this next number factored in that interest earned after the first compound. Bank three, if it's compounded quarterly, a little bit bigger. Bank four, even bigger. And bank five, even bigger. Now it's not a ton more money, but also when we're talking about investing $1,200 is not very much money either. So keep in mind that the more often it's compounded, the higher the ending balance will be because it's earning interest on the interest. Okay, that's the whole idea with compound interest. There's not like anything to do on this problem. It was just like, hey, notice this. Let's talk about it. So see how those values are similar, but a little bit different. Same interest rate, but compounded more frequently will result in a higher balance. Okay, next problem. Here we go. This is the juice of what we're doing today. Okay, so a couple of formulas for you. There's 3 separate formulas. The letters stand for the same thing in each formula. Okay, now some formulas have different letters, right? This first formula, sometimes it says A equals, sometimes it says B equals. Okay, so we're just going to go ahead and say either way, that stands for how much money you have in your account at the end. So it's not your interest earned. It's your ending balance. It's how much money is in the account. That's really good news. That's going to save you a step based on the formula we were doing yesterday. Now, P, that's the same thing we were doing yesterday. P is still your principal. That's how much money you start with, how much money you deposit in your account. R, same thing we were doing yesterday. R is still your interest rate. Okay, but remember that has to be switched to decimal form. Got to move the decimal before you plug in. N, this is kind of the important thing, the new thing we're doing today. N stands for the number of times compounded per year. Okay, and we talked about that in that table at the beginning. So if it's compounded annually, N will equal 1 time per year. Semi-annually, N will equal 2. Quarterly, N will equal 4. Monthly, N equals 12. Weekly, N equals 52. And daily, N equals 365. T is still our time measured in years. Okay, and then APY, that one's a little bit different. APY, that one is not when we're looking for our annual balance. APY, remember, is when we are looking for our annual percentage yield. Okay, let's look at our first example with the formulas. So Nancy deposits $1,200 into an account that pays 1.7% interest, compounded monthly. What is her ending balance after 1 year, round to the nearest cent? Okay, so her balance is what we are looking for. We don't know what her ending balance will be. Her principal, she is depositing $1,200 into her account. And her interest rate, 1.7% interest. Remember, we got to switch the decimal though. So that would be 0.017. That's what R equals. N, how often is it compounding? Compounded monthly. So N is going to be 12. Because it will be compounded 12 times per year, once after each of those 12 months in a year. And T, time after 1 year, so T will equal 1. All right, so I'm using this formula right here. Okay, we could have used this one too, but I wrote B equals, so we'll use the one that says B equals. Okay, so using that formula, I don't know what B is, so it'll just be B equals P, which is 1,200. And then you see those parentheses? The times 1 plus. That 1 plus is always going to be there. I'm not changing that value. It always has the 1 plus. And then there's R, which I know to be 0.017 divided by N, which is 12. And then I close my parenthesis, and then N is my exponent, and that's 12 times T, which is 1. Now, these are being multiplied together in the exponent. So when you are plugging that into your calculator, basically in my calculator, I make my screen look exactly like this whole formula. Plug it in all together. So I would type 1200, 1200, parenthesis, 1 plus, fraction button, remember N over D, put 0.017 in the top, arrow down so you can get in the bottom, type 12, and then arrow over to the right. Push the right arrow button, close your parenthesis, and then the exponent button. The exponent button is going to look kind of like this. Okay, that's a button on your calculator. And then you're going to type 12 times 1 and hit enter. Okay, and when you do that, it should tell you 2,470.485. If you did not get that number on your calculator, pause the video. Let me help you right now before we keep going. Okay, when you're doing these problems, typing it in your calculator is half the battle. So definitely make sure that your calculator can give you that number too. Don't just write it and keep going. Take the time, practice, plug it in. If you're not getting that number, let me help you. Okay, so that is our ending balance. Now we want to round to the nearest cent, round like money. So our answer is going to be $2,470 and, okay, so when I'm rounding, I'm going to keep the 4 and then the 8 right here, because the number that comes after the 8 is 5 or bigger, I'm going to round up to 9. Okay, the 5 is going to force the 8 to become a 9. So this would be 49 cents. And that's how much money would be in her deposit or in her balance in her account if she deposits $1,200, earns 1.7% interest, it's compounded monthly. After 1 year, she's going to have that much money in her account. Next example says Kate deposits $2,350 in an account that earns interest at a rate of 1% compounded daily. What is her ending balance after 5 years? And we're still going to round to the nearest cent. Okay, so I'm looking for her ending balance. I don't know what it is. P, how much money is she depositing? $2,350. What's the interest rate? 1%. As a decimal, that's going to be 0.01. Okay, make sure it's 0.1. 0.1 would be 10%. It's got to be 0.01. N, how often is it being compounded in 1 year? It's compounded daily, so that tells me that N equals 365 because there's 365 days in a year. And if you're looking at this chart right here, tells you compounded daily right there. Okay, and then time, how long is she doing this for? 5 years, so T is going to equal 5. Okay, so I plug it in into my formula. My formula says B equals P, which is 2,350 times, remember, there's always going to be that 1 plus and then a fraction. Inside the fraction, we put our R, 0.01 in the top, and our N, 365 in the bottom. Close your parentheses, and then in the exponents, we're going to multiply N, 365, times T, which is 5. Type that all into your calculator again. Make sure that your calculator tells you that B equals, oh no, I just realized I made a mistake on the last problem because this is what my calculator tells me on this problem. Shooting. Okay, this one, the answer is 2,470.49. I got to go back. This is not right. I looked at the wrong part of my notes. My apologies, everyone. Okay, so we're going back in time. And it's like, nope, you can't erase that. It's been too long. Okay, let's see. There we go. Okay, so we're going back in time. Right here on this previous example, my mistake. B was not supposed to equal that number. B was supposed to equal 1,220.559. When we round this, so I'm trying to decide if I keep that a 5 or I bump it up because this is 9. It's bigger than 5. I'm going to round up. So this will be 1,220.56. That should have been my answer on this problem. So sorry about this. So example 2, there's my answer. And example 3 should have had that answer. Bear with me, people. Okay, last example I think for today. Barbara deposits $3,000 in a 1-year CD at 2% interest compounded daily. What is the annual percentage yield to the nearest 100th of a percent? Okay, so remember, this is what we are looking for. We are using a different formula this time. APY is what it asked for, so we're going to use the APY formula. And that one looks like 1 plus R over N to the N minus 1. So to use this formula, I need to know what R is. Our interest rate is 2%. When you switch it to decimal form, that should be 0.02. And our N, compounded daily, so N will equal 365. Okay, so in my formula, APY will equal, there's always going to be this parenthesis, 1 plus fraction. In the top, I put the interest rate. In the bottom, I put the N. It's compounded 365 times a year. And then N is going to be the exponent up here, okay? And then that minus 1 is not part of the exponent. So when you type that in your calculator, you're going to go parenthesis, 1 plus fraction, 0.02 divided by 3.6, or divided by 365, 0.02 in the top, 365 in the bottom. Close your parenthesis, hit that exponent button again. Remember, it looks like this. Put 365k, and then you need to make sure you arrow over. Push the arrow button to get out of the exponent, then do the -1. When you do that, telling you the right number here this time, you should get 0.02020. If you do not get that number, let me come help you now. Okay, so APY is a percentage. Remember, the P stands for percentage. So what I'm going to do is move my decimal 2 places to the right or multiply it by 100. This would be 2.020%. Now, the instructions told me to round to the nearest hundredth of a percent. So hundredth, I want to include just 2 numbers after the decimal place. So my answer is 2.02%. And I believe that's the end of our notes. All right, go ahead and practice your practice problems. Let me know if you need any help.